So here we have our four standard graphs that we should learn. Right, first graph is a straight line. Right, first graph is a straight line. Second graph is the quadratic that we all know. Third graph is a cubic, and the last graph is the graph of y is 1 on x. Right. On the graph y is 1 on x, remember the x-axis and the y-axis are asymptotes. Okay. All right, so that's right down in case I forgot about asymptotes. For the graph, y is 1 on x. For the graph, y is 1 on x. The x-axis and the y-axis are asymptotes. Huh? Which one? Cubic. All right. So can you see that there? Oh, wait. All right. So we're going to learn about some transformations, right? Kind of transformations, and we're going to go through each one individually. Right? Kind of transformations. And you can take it back. All right. Take it down, send a message to everyone. And come up, right? All right. So we're looking at the first thing. The first transformation that we're going to learn, if I gave you a function f of x and I multiply x by a, what that will do to the function, that will stretch the function along x-axis by a factor of 1 on a. Right? I'm going to show you an example now, right? Watch this here. Let's say f of x is that. You're seeing that too small. See that? Right? Let's say f of x is equal to y is x squared. And I said sketch y is equal to 3x squared. It's a little hard to show, but I'll show you using a different color, right? I'll use the fluorescent green, hopefully you'll see it. Right? If I were to multiply x by a, what I have to do is stretch along x-axis by 1 on a. So along the x-axis is here, and I have to stretch it by a factor of 1 on 3. So all that simply means is that 3x squared will look like this. That's okay? I'm changing number so you would agree. Some of you all do agree. If I said 2x squared, I'm going to stretch it by a factor of a half. That's okay? What does a half mean? A half mean I'm bringing the t. Right? So it will look like this. Stretch by it's a stretch by a factor of 1 on it. All right. Let's say it was this marquise. Let's say it was a changing in color again. So what? Purple. All right. So let's say marquise I said 1 on 2 x. Then I'm going to stretch it by a factor of what? 1 over 1 on 2, right? Which is 2.
Yes, sir. Yeah.
Right? So if it were half x, then it will be, so if it were half x squared, then the stretch will look something like this. As again, twice as wide. So looking like a stretch now?
Yes.
Right? It looking like a push-up thing, right? Are you okay with that? So whenever you multiply a by a value, you stretch along the x-axis by a factor 1 on 8. That's okay? Right? I know it's slightly untidy, but write number 1 and write those 3 examples now. 2 examples.
Wait, I haven't seen any examples here. Like, when I serious thing, like, what we're talking about, like, nah.
Alright, right. Let's first answer on the board. I'll do all on the board, right? Write down all transformation. Take it with this handout, then. Hold on, module 1 stuff. No? This on the element. This is the first thing on the element. And underneath it have a list of summaries. Mark it open right now. Oh yeah. Right, also hold on, then I'll explain it, right? Questions? All right, good. All right, they're ready? I'm moving up, right? Only one I'm moving. I just move one. Right, but this whole thing on the group, anyway, go ahead. It is on the group and it is in the element.
Really?
Check on the element. Anyway, right, take quick, right, take quick.
And not only you.
Yeah.
I'll sign it off, right?
Senate, not back,
Back.
not back.
Yeah, I'm gonna do it.
No, I didn't look out, so I don't.
Right, on the group, but those who want the notes in order, you'll put out. Write it out, right? So you put some kind of like this, the lead on the group on
Anyways,
7.
on the group, and just the text.
If they are on the group,
I mean, not even funny LMS, and then in the topic book, the textbooks and book.
but probably hit up, but I see.
So where do you come from?
I don't know why it hit up. However, them came. Right, oh yeah. You're finished with 2. So whenever you're multiplying, no, all I just will write e by x and y represent. So yeah, probably everything. Okay, so when you multiply x by a is a stretch along the x. When you multiply the whole function by a, it's a stretch along the y. When you add x to a, you shift it where? To the left a, right? That's okay? You shift it to the left a. And if it's negative, you shift it to the right. Right? When you add a to the function, you shift it upwards. When you minus a, you shift it downward. Right, but please write them quick so you always know what talking about when I go through the examples, right? When you add A, you ship it up. When you minus A, you ship it down. When you minus the X, you reflect in the Y-axis. When you minus f of X, you reflect in the X-axis. That one has a small error. Anybody know what it is? I didn't think it does yet, but that one has a small error. Reflect anything below the X above. I didn't think it does yet, but some of you may have done it. Now, I know you do it already in soon.
We do this already.
Until you finish this module already.
All I did is one. No, I mean,
Why you family and check some factors?
yeah.
I might do two, so that might go.
Oh, yeah, man.
I might. Anybody online recognize 7? Something missing. There was small error in 7. Small error. 2 little strokes.
Oh,
Modulus. Right? Modulus. Well done, Yash. Ali, I remember that. Modulus. Like modulus. Right? So yeah, 7 have a small error. It should be modulus in between the f of, around the f of x. All right. Copy that down and let's go back to the code and let's apply it to B and C, B and D. And not bother with A and D so much. That's okay? Okay, right. If you miss anything, it's in the little thing as sending, right? On the transformation. Taking it off, right?
yeah.
Ready? Taking it off, right? All right, so. Right. So watch this here now. All right. So we're gonna take K-sharp, we're gonna take B and D, and we're going to do 1, 2, we're gonna do these 3, right? Right? These 3 is kind of popular. So first thing first, right? If I wanted to transform f of x with a minus in front of it, what do I do based on transformations? What do I do? Reflect in the x-axis. Okay? So I'm going to reflect this in the x-axis, right? That's part 1. So I'm going to reflect this. This is the x-axis. So when I reflect it, it looks like this. So this here is the function of y is equal to minus x squared. Okay? So by just simply knowing this, we can get this. All okay with that? What about here? If I do it here. If I reflect this in the x-axis, what would I get? If I reflect this curve in the x-axis, I'll get here. Right? And if I reflect this in the x-axis, I'll get it here. Okay with that? So this is the graph of y is equal to minus 1 on x. You okay with that? What about 2? F of x plus 3. What does plusing 3 to the entire function do? Shift it upwards 3 units. So I could shift this function, that's part 2. I could shift this function upwards 3. Well, what is this point here? 0, 0, right? So if I shift it upwards 3, it looks like that. That's okay? This is f of x plus 3. Or to be more exact, this is x squared plus 3. Yeah? That's it? You okay with that? This is x squared plus 3. All right? And what about here? What about this one here? How would I get the entire function plus 3? What would I do? Right? What am I gonna do? Shift the whole thing upwards 3. So watch this here. There is something that will change. Anybody can tell me what that something is? When I shift this upwards 1, I'm bringing the whole graph here. 1, 2, 3. What will change? What's the word? The asymptote. Right? The asymptote will no longer be the x-axis. The asymptote will be 1, 2, 3 up. Let's pretend it's here. What is called that line? X equal to 3. Y is 3. So you just call this line here one line. Y is equal to 3. Right? So shipping the whole graph up 1, 2, 3. So this stays the same and this stays the same. Right? You'll recognize that the curve will now cut the x-axis, right? Because the x-axis is no longer the asymptote. Right? The asymptote is now y is equal to 3. Everybody okay with that? Yeah? All right. So I want to challenge you slightly. Do part 3 for me. Do part 3 for both of them. Right? I did 1 and 2 for you. See if you can do part 3. Copy down 1 and 2, and then try part 3. Online? All okay? Karen, you can show? What? Okay, so copy down B part 1 and 2. D part 1 and 2. And I just want you to figure out 3 for me for each one. Those who finish corner, right? Yeah. Oh yeah. Yeah, yeah. Part three. Yeah. Yeah, from B and B to the part three. Online, if you want to check it, you can send my WhatsApp, right? Okay, then which you put there? It's not working, yeah, the pass all the way around. Oh, how did I answer on back there now? No. Did I any against me? Chief. Dave, see what? Send my WhatsApp, yeah? Oh, why? I spelled J-E-Y. Ah, no.
That's. Say, check the answer.
I passed there already. Right, anybody on the watch, anybody online, not in the WhatsApp group? All right, so let's see, right? So this one here is I like to do it in different stages, right? You could do it two ways. So if I look at part three, you'd recognize that they have minus f of x, then they add 3, right? So I can write this a little bit differently. I can write minus f of x plus 3. So you're going to reflect f of x in the x-axis and then move it upwards 3. Fair enough? Right? So reflect in the x, move it upwards 3. So I can reflect in the x, move it up 3. So it will look like this. That's okay. Or I can move it up 3 and then reflect. Anyone will give me the same thing. All right. So what you have to be able to list out earlier is the order of the order that you want to go in, right? So minus, then the plus 3, reflect in the x, and then move up 3. Okay? All right, sometimes I like to do it like step 1, then step 2, right? Jesse, you okay with that? Darian, you get that? Online, you all okay with that? So this here, this function here is f of x minus f of x plus 3. I wrote the f of x first because it's easier to see that we're reflecting than adding 3. And last one, Kamiko. Ariana, are you okay online? Right, and last one, part 3D. Part 3D. Where is it? Right. So part 3, you'll recognize that we go into reflecting the x-axis and then move it up 3. Okay? So reflecting the x-axis here, and now I can move up this whole thing 3. All right? So for those who lost, let me just do it together in one for you, right? Watch this here. So the question said in part 3, Esther, I'll bring on the board for the next one, right? Just to make sure you get into it. Minus f of x, I'm reflecting in the x-axis, then I'm going to add 3 to it. Okay? So I'm going to take this function, I'm going to do stage 1. Stage 1, I'm going to reflect in the x-axis. So I'm going to reflect it here and here. Correct? Now, step 2. So this is minus f of x. Step 2 now, I'm going to add 3. Okay? So I'm going to take this, move it up 3, take this, move it up 3. I will have a asymptote fall, y is 3. You have to write the asymptote, right? So it will look like this. That's the final answer for minus f of x plus 3. That's okay? Right? Keisha, 1, 2 to do. No problem, Keisha. Yeah? No, minus f of x is. No, minus f of x for b was the quadratic. F of x for d is this. I gave it, remember I gave you these 3 examples for this one. And then these 3 for this function. It's 2 different functions there. I know it. Let me simplify it now, giving you one alone now. Online, any questions? Chelsea? Luke, are you okay? All right, so we are going to jump into this.
I don't really know. They are.
All right, so we're going to number 1. So look at number 1. What is the base function for number 1, Marcus? Look at this here. What's the base function for number 1?
X plus minus.
No. What's the base function? Out of the 4 functions I gave you at the start of the class, which function you think this is?
Second one.
Y is equal to x squared. Nice. Second thing. What are the transformations undergoing, Darian? What's the transformation? This y is equal to x squared undergoing. Seeing 2 transformations here?
Yes.
Right? Start with this one now. What it says?
Shift.
Shift where?
So
Minus means where? Left or right? Up or down? Minus, no. Minus means what?
right.
Right. To the right, 2. Yeah. Check the rule. Check the rule. Right? And positive 4 is what? 4 upward. That's okay? Alright, so you have to, so here it's a little bit in reverse, right? In reverse. When it's a minus, they're going to the right. When it's a plus, they're going to the left. Okay? So you have to learn them, right? So these are the 3 stages that I'm going to take. Are you okay? Right? Okay then. These are the 3 stages that we're going to take. Stage 1, we're going to start with y is x squared. Stage 2, we're going to shift it to the right 2. And stage 3, we're shifting it up 4. You understand with that? Right? So watch here. I'll try it first. We have to do it. Watch it. I'm gonna do this one, right? And I'll let you try the next one, right? So I'm starting here. I am starting at y is equal to x squared. 2. I am going to shift it to the right 2. So I'm shifting this whole function to the right 2. So this value is now 2. Right? So step 1, x squared. Step 2, I shift it to the right. Step 3, I'm going to move it from right here. I'm going to move it upwards 4. Hold on. I'm going to move it upwards 4, right? So it'll be right here. I'm moving it upwards 4. So the x value is 2 and the y value is 4. You okay with that? Yes, Victoria? Right? You don't have to do this, huh? I just doing this for you to show you all the stages. Right? So stage 1, you have to recognize the base function here. The base function is x squared. Right? Minus means we shift into the right 2. I did it here. I shift the whole function to the right 2. And lastly, plus 4 means it going upwards 4. Okay? Let's go again. This curve sketching is very important. Huh? It's come module 1 and 3, right? No problem. That's a good idea. I'll go copy. Right, let me make sure online okay there. Kamiko answering, Yash, good. Let me see. Iowa, you okay? Prescott didn't answer. Kiran. Kalina always listening. Kayla will be listening. Look at that. Barrage, you okay? All right, nice. Luke, I seem to have lost Luke. Right. What about this name? Right, Sagarita. You okay? So far? Right, because I want to call somebody on the board for this one. No, I'm not saying this dude. Musa is Esther, between Esther and Esther and Luke. All right, let me keep it simple for this one before I complicate it, right? Oh wait, we're going till 7 underwater. I can do more examples. All right, keeping it simple there, right? I'm keeping it simple. Right, try number 4. Sorry, try number 2 and number 3. Take your time, try number 2. Number 3, you have to figure out what the base function is, right? Why are you looking like Esther for number 3? What do you think the base function is?
Start thinking like.
Which one? The one on X, right? The one on X function, right? Go ahead. Try number 2 and 3 if you have it. Show me. Okay, one time. Oh, wait, yeah.
Yeah, okay. Anyway. Wait. And remember for number 3, you have to write linear asymptotes, right? Don't just move it. Write the equations of the asymptotes.
I let's go. Right now, don't kill us now. You know how you ask him to talk more like All right, online. I'm sure you have here now. Any answers? Let me see, where's my marker? Right, this one here. This one here, I am starting with y is equal to x squared. Then I am adding 3. So I go into the left 3. And then here, minus 2 means I am moving downwards 2. Okay? Please remember, right? The point that really moving is this 0, 0 point, right? That 0, 0 point is what is being transformed. So I'm taking 0, 0 and I'm moving it to the right. So I'm starting here. Next step, I go in and shift it to the right 3. So it will be here. The point here is minus 3. And then I'm going to shift it downwards 2. So it will look like this. That point there is already minus 3. So you can leave minus 3 here. And you move it downwards, minus 2. I like to write the actual point, the minimum point. That'll be minus 3, minus 2. All right, online? So I recognize that the base function was y is x squared. I should move it to the left 3, right? 1, 2, 3, and then I move it downwards 2, 1, 2. So That is the equation. Right? Now this one here, the base function. The base function is y is equal to 1 on x. The second thing is we are going to move to the left 2, because there's a plus 2 inside here. And the third thing is that we're going down 3. No need to put minus, right? Just put down 3. This one I'm going to do a little different, right? This one here, I'm going to start with the base function. Try and draw your curves a little smooth, right? Esther? Right? Here's how you can practice drawing it, right? Here's how you can practice drawing it. Start it close here and finish it close here. So you get it curve a little bit. Not that thing that you have there, right? This one kind of bad. Right, nice. So this one here, we're doing them together one time. Okay? So the shift here is this. Right. The shift here is 2 to the left. So a shift in the asymptote to the left 2. Okay? So the asymptote to the left 2 means that the asymptote is x is equal to minus 2. That's okay? Yeah? And I'm going to shift it down. So I'm going to shift the asymptote from the y-axis to 3 points downwards, which is y is equal to minus 3. Right? If you shift the graph without the asymptotes, you don't know what function is, so it's wrong. Right? You must have the asymptotes. Okay? And then it will look like this. Right? So you're drawing back this same thing and just those pieces there. Okay? Yeah? Online, any questions? Any questions, Olia? Everybody okay online? Chanel? Kalina? You okay? Ruben? Ginger?
Look, I can't think what so what is it? Because you feel like darker skin to shiny white. What is that to turn white? You see, I know it's about black because yeah.
Oh, yeah, Justin.
Yeah.
Okay. All right, nice. You're okay with this? Right? But the problem is you have to learn all 7 transformations, right? Right? I want to focus on the 7th one a little while, right? Everybody okay with this? Right. I have a function I want to give you, right? Right? I have a function I want to give you. I'm looking for some ideas, right? Get this out and then we are finishing class now.
Yes. Lying by. Sir, but we think I 10 minute break after this.
Yeah.
Okay, all right, yeah, I'll give you a 10-minute break if we get this one out. If we get it out, we get a 10-minute break. Yeah. Right. So let's say I gave you something like that, right? This came in exams a few years ago, something looking like that. And they asked you to sketch it. Actually, I have to reflect it. Yeah, sketch it. How are we doing that? Right? The hint I want to give you is that we do it already. How are we doing that? That looking like any of the base functions I give you? Huh?
Yes. Sir.
Which one looks like? 1 on x probably, okay. 1 on x, that's a good start. But how do I get rid of the x on top then?
So.
So. It's closing, yes, in the right, along the right lines. Huh? Make it a quadratic. Anybody online? What we can do here? So the answer is yes, it looks like 1 on x, right? But this is not in the form right now of 1 on x. How?
Minus 3x minus 5 1 on x.
Minus 3x over. No,
I got one.
no,
You got it.
no, couple over 1.
Oh. So yes.
I want to understand.
Root b minus 3x minus 5 1 to the right hand side. Power 1 minus 1 is b minus 3x minus 7. He just b minus 3x
And then multiply. But I still wouldn't give you a function like this. But you're close to it. You're close to it. Anybody online have an idea? Kamiko? Right, but that's a multiply now. Hold on, sketch that. Right. You're close to it, but it's something else you have to do. You're close to it. You sure? So here's what you're saying. All right, tell me what you're saying. Tell me what you're saying. Minus 3x. How you doing now?
Alright. Minus 3x minus 5 multiply 1 over x plus 2.
So that one was
All right, what going to do after? What going to do after?
Right, so you know what you do, right? Now, you're doing 1 with 1 over x and then 1 over
All right, what is this here?
divide.
Divide, right? So
Oh shit.
how about if we divide?
Nah, but you lost it.
Right? Since it's saying, right? Since it's saying this divided by this, it might be a good idea to divide, right? Right? Let's just divide and see what will happen, right? X into minus 3x is what? Minus 3, right? Minus 3 by x is minus 3 by plus 2 is minus minus. This is 0 and this is 1. How do I write this back now? And this is remainder and this is quotient. So it means that y is really what? Minus 3 plus 1 over
X plus 2.
Can we sketch this?
So then I was saying possible.
Yeah.
Yes, that's not.
All right. I don't know. Are you okay with that? Can we sketch this now? You recognize that?
Yeah.
This is the same as that. Right?
Yeah, 10 minutes.
So let's just do my favor. Do my favor, right? Note that number 3 could also be written like this, right? Let's make a note of that now, please. Anybody, any ideas online there? Online's quiet, but I wanna find out way to get them, keep the mics in. Yeah, note that number 3 can also be written in that form. Ah. No, that's not problem. Yeah, same thing, same thing. I was just trying to show you that, right? I was just trying to show you the same thing.
Like, you really, yeah, just do yeah. No,
Right, this online is really interactive.
I'm back.
Olia, please remember, right? If you have like a number on top here, like 3 or something, right? That's just a vertical stretch. You can't really show that too much here. Right? It's difficult for you to show that it's stretched, right? All you have to do is just say there's a vertical stretch of whatever. It's difficult to draw this and stretch it 3 times.
Take out, that is when we were gonna upgrade, guys, see number 4, we're not there, I get scared.
I don't know. I think to get out again.
We get.
We get-
Get out.
You just take it from it.
Do this one. I'll give you 5 minutes.
That way,
No, no, no,
that's
5 minutes.
That's right.
Because it didn't get it out, so it's 5 minutes.
Yeah, they do it first.
Right, catch that there. Oh, yes. Catch number 4, I'll give you 5 minutes and then one off, right?
I know you want those, right?
Just logging on, man.
No. What online?
Yeah, online course.
Uh,
It is this number 4, right? Just catch this one for now. Yeah, now I don't know whether or not. We have a whole step as a player. Oh yeah, last one, then I'll give you 5 minutes and then we do more. 5 minutes. Oh, I didn't extend the class to give all the time. I'll give you 5. That's great. Oh yeah, so do your long division and then do your sketch. And then we'll spend the last few minutes on modulus. After the 5 minute break, oh gosh. That's gonna keep each other on and off. Yeah, look at the rules. Flux. Flux is right. Right, so do your long division and then the marquis. Your breaks out now, your break almost done.
I better.
You don't divide already?
Yes.
Yeah. Second. No, serious. Hey, sir, come check it.
Yeah.
No, you know, check it.
Alright, let's see, long divide. Long divide 4x minus 7. You'll get 4, here you'll get 4x minus 8. Here is 0 and here is 1, right? So you're getting 4 plus 1 on x minus 2. So you're shifting upwards 4 and to the right 2. So your asymptotes here. And your asymptotes. Right? Y is 4, x is 2. Okay, so it looks like right, no reflections, right? Okay. That's it. Question, if there's a minus here, I just asked a question, I said 5 minutes.
10.
If there's a minus here, what you would do?
If what was the minus?
If there's a minus in the middle here. Right, reflecting the x asymptote, right? Not axis, asymptote. If it had a minus sign here. Okay? All right. Take a little break and then we focus on the modular. Your break is until 7 minutes long. 7 minutes. Well, let's not make it those times. I don't want to half an hour and then we minus in that time, huh? So I'm not taking it back and finishing it 10 past 7. All right. Right, start back at 6:30 and then we will continue with modular, right?
Sir,
Yeah.
good job.
No, 7 minutes for the better start fast.
Yes. Hurry up, no.
Alright, let's go. Come on here.
Right.
Let's continue. Let's focus on modulus now. Alright. Modulus, right? So I just want to focus on the modulus a little bit, our function. Right, set up modulus. Right, what did step 7 say? What did step 7 say? Right, yeah. What did example, what did transformation 7 say again? If you have a modulus, right, reflect anything below the x-axis above. Okay, so looks like that, right? That's okay. And that was the original thing there. And that was the original thing. So I'm going to reflect this part here. You're only reflecting the part of the graph that's below the x-axis. So that's this part here. So you're reflecting that up here. So it looks like that. Right? So what you recognize about the modulus? Does it have any negative values? Right? So the modulus only gives a positive value. Right? We technically call them the absolute values, right? So modulus only gives positive values. Anybody can probably guess how this is achieved? How you can achieve something like this? Right. All negative values become positive by multiplying by -1. That could work. So how do I make -3 positive? Multiply by -1, right? So technically, that's what you're doing whenever you see the term modulus. Okay? So I'm going to give you a definition for modulus, right? All right, so the modulus of x is defined like this. Right? Wait now, where am I? That was on that? All right. What's in here? What's here, right? Actually, take up. What's here, right? So how do we define the modulus of x? The modulus of x, when x is more than 0, right, is x. Because and all these values are more than 0, so we can leave it as x, right? But when x is less than 0, when x is more than 0, we leave the values as x. But when the values are less than 0, we define them as being minus x. That's okay? So this is the definition of modulus. When the x values are more than 0, the function stays as it is. When the x values are less than 0, the function is now minus x. So technically, all these values here were less than 0, so they became minus x. So minus of a minus gave you positive. Okay? So all these negative values became positive. Yes? So that is the definition of a modulus. Okay? Before we give you some calculations, let's see if we could catch one now. And then I'll give you a calculation. But okay with this? Victoria, you see about this link there, right? Right. Just do one slightly tricky modulus. Right, just catch that fast now. Modulus of 1 over x plus 3. I don't give you a full, and then we take a look at solving these modulus, right? Huh? Pardon me? You have to do this. Right, so when you're reading it, it'll be an example. When you're reading it, that'll be an example. Yeah, when you're reading, you'll see example 1 and you'll see the answer. Just do the thing now, boys. Catch it. Right, Darren, since you're excited to do this one, help me out now. Right, how are we doing this? What's the first thing we should probably do? That's the last thing. Right, but what's the first thing we should probably sketch then? Forget the marks, yeah? Okay, so tell me how to sketch this then. What are we starting with? What's the base function we started with now, right? Y is what? Y is 1 on x. Then what we doing? Huh? Which means you're going to the left 3. So you start with the base, you move to the left 3, and then what? Modulus means you're reflecting the right? You reflect the negative part in the x-axis. Okay? That's all we're doing, right? So we start in here, then we shipping it 3, and then we're reflecting in the x. That's okay? So we starting with 1 on x. I am squeezing it in here. We starting with 1 on x. Then we shipping it to the left 3. That's okay? Start here, shift to the left 3, and then lastly, we're going to reflect the negative parts. See that? Marquis? Yeah? You're seeing the negative parts. What we're going to do this negative part here, Marquis?
Yeah, take it in.
What's this thing in this?
Yeah.
So you're reflecting the negative part up here. right? What about this? Do I have to reflect it down here?
No.
No, because it's modulus, right? Only the negative part becomes positive. Right? Okay. Copy it down, and I want to show you how to do. Right. I start with 1 on X. Then I shift it to the left 3. So I shift the whole graph to the left 3. And then I apply modulus. Modulus means the reflected negative part in the x-axis. So this will be up here. Okay, so that is the graph of this. Chelsea, you okay with that? Faraj, are you okay with this, Faraj?
You right. Sorry. We have a live or it is good. I was given maybe. Yes, should I say?
Yeah.
Yeah.
The live, I'll leave the live on the channel. I'll lock up some of them. Right now, everything will work now. Stop it down, and then we're going to try to solve that question, right? The number 2 is the actual solving, right? I'll show you 2 methods, but I will only be focusing on one afterwards. Ready? Keshav. So Keshav, right? Here's our problem, right, Keshav? We have to solve things like this. Right, Keshav? So we have to solve functions that look like this, right? In order to solve functions like this, we have to consider 2 things, right? We have to consider when x is more than 0, and we have to consider when x is less than 0. Right? When x is more than 0, what we know? When x is more than 0, we know the function stays the same. Right? So the function stays as this, positive 2x plus 1. But when the function is less than 0, we have to work it as a minus. That's okay? This is method 1. Method 2 that I don't really do is square both sides and work it out. Okay? Square both sides is work out nice sometimes, like here. But square both sides doesn't work out too nice here. Okay? So you can choose when to use it. Square both sides nice here. You can square both sides here and work it out. It's up to you. But I like this method, right? I like to work it like this. So this will be 2x plus 1 is 3. This will be 2x is 2, x is 1 here. Minus 2x minus 1 is 3. Minus 2x is 4. X is minus 2. That's okay? Here now. Right? Here now. Here. What we could do, I'll show you method 2 in this case. What we could do here to remove the modulus, because if I square both sides, squaring both sides will make sure that it always stays positive, right? Right? If I square here, I'll get 16x squared plus 24x plus 9. Here I will get 4x squared minus 4x plus 1. When you work it out, you will end up with 12x squared plus 28x plus 8 is 0. Make it help with that. So the calculator now, come away again. X is what? Twelve x squared plus 28x plus minus a 2 done. You got it? Get it? What I mean? Okay, play again this side. Okay, and all okay with that? So you can square both sides and work them out and get the values. And here, lastly, what is one here? If you see one like this, don't use squaring both sides, right? It turns it into a quadratic and then don't do that. Highest power is 4. Right? So you bring right? It turns it into an equation with x to the power of 4. So technically, that this guy is quadratic, it turns it into. Yeah. So what you'll do here is use the definition again. So when x is more than 0, online, you're seeing this? The marker cannot die. You're seeing this? X is more than 0, and this is x is less than 0. Yeah, you're seeing it still? All right. So when x is more than 0, this here stays positive. When x is less than 0, this becomes negative, right? So you write it like this. 2x squared minus x plus 3 equal to 0. And here will be 2x squared, right? Less than 0 means that x is negative. So this becomes positive x plus 3 is 0. Right? And tell me what you get here in the calculator. Tell me what you get here, right? This might be no solution. Now they have no use solution. I make it up to the word. Most important thing is you know what to do if you see it, right? Huh? Oh, so you get one value. I know I in it, right? No. This one solution. B squared minus 4ac is less than 0. All right, online. So that's the way you handle questions like that, right? That's the way we handle questions like this. Copy them down now, please. Right? It'll really come out different than that, right? So I'll give you one pass me quickly. Alright, try these two past papers here. Alright, try those two past papers, 5x minus 6. What the? Oh yeah, try the inequality and then try number 5. I have a slight problem with the inequality, right? No, do 5 and 6. 5 easy. But you have to remember something from form 4 in number 6. Right, last one we got.
Ready?
Yep, that's it. Two minutes to do it, 2 minutes, 1 minute, like that. Yeah, treat the play. Right, we're going to one.
I think.
Excuse, hold on. Okay, hold on. See that? See that? Talking about it, okay. You gotta finish. Both of that. 5 answer. Oh. I'm doing this one, right? Right, one is more than 0. It's plus 5x minus 6 is x plus 5. So I got 4x is 11, x is 11 on 4. Got to get that? When it's minus, it's minus 5x on 6. Right, so I got minus 5x plus 6 is x minus 5. Anybody get that? 11 on 6.
Yeah.
11 on 6.
I get out of it. Stop.
I multiply wrong. For sure. So this plus become my mind. Oh, sorry then. One six. Yeah. 1 6. Sorry about that. Right here we have to remember something, right? We have to remember when it's a plus. When it's a plus, it will be 3x minus 4 is less than or equal to 6. 3x is less than or equal to 10. X is less than or equal to 10 on 3. Right? That's okay, right? But when it's negative, we have to remember this. If you want to carry the negative sign here, it becomes minus 3 on 4 is more than or equal to minus 6. You'll get 3x is more than or equal to minus 2. X is more than or equal to minus 2 on 3. Okay? So these are our two solutions. Let's have an equal sign. Oh, because I just expanded out, I could have done that as well. I could have put the minus 3 here. So I would have gotten 2x plus 1 is minus 3. Now get the same answer. Right? Right? But the reason I put the minus here to make sure you remember to convert the sign, right? All right, online?